Alright, welcome back to Economics. This is Dr. Kling. Today's topic is profit maximization. So, how much do we produce if we're a firm? Do we produce or sell in order to make the most profit? So we'll be drawing a picture with profit, which we'll call pi. So pi is profit. So in macroeconomics, pi is inflation. In microeconomics, it's profit. Go figure. Alright, so pi is profit, and Q is the amount of output. Now, if we don't produce enough output, we actually lose money. So this point here, we can call B, is the break-even point. In the there's a shopping center right near where I live, and a guy there sells snow cones off of a cart. He brings a cart, he parks it in front of one of the stores, and he sells snow cones. Only he's not there now, and that's because I'm recording this in November, and he's only there in the summer. And my guess is the reason that the guy with the snow cones is only there in the summer is that he can't sell enough snow cones to break even when when the weather's cold and when the weather's bad. So that's part. So you have to first make it to the break-even point, and then you think, well, the more you sell, like the more snow cones the guy sells, the more and more profit he makes. But eventually it starts to come down. In fact, could be negative again. That is, he'd have, maybe in order to sell this, and the reason it sort of starts to come down and becomes negative is that in order to sell more snow cones, the guy at some point would have to cut his price. And he'd have to make his price lower and lower, and by the time he's, let's say here, he's selling them for more than the cost of making them, and that's why he's losing money here. So somewhere in between is there this sort of magical point we'll call Q star, which is the point where at Q star profit is at a maximum. Now, we're looking down at this graph, and we can see the whole thing, and we can say, the maximum's right here, or go to Q star. Imagine you were a little ant crawling along this somewhere over here, and you couldn't see the whole graph, but you could see every time you increase quantity how much more profit you get. So, and I'll call that delta pi over delta Q. And I'll also call that pi prime. Don't ask why. And that is how much more profit you get from producing or selling one more unit. Okay, so we've got this, so we can tell whether, so we have this, the rate at which profit is going up as we sell more output. And so one of the things to notice, to think about, if you're this ant crawling, all along here, this side, your profit is going up as you move to the right, as you add more output. But then when you get to the maximum, as you move to the right, the profit starts to go down. So this thing, this more profit you get, is, so this pi prime thing is greater than 0 to the left of the maximum, and it's less than 0 to the right, and it's equal to 0 at the maximum. So this little ant can figure out where the maximum is by noticing when this pi prime becomes 0. And that, my friends, was sneaking in about a semester's worth of calculus without anyone knowing. Okay, so pi prime equals 0 is the maximum. Now the pi you can think of as total revenue, that is price times quantity, minus total cost. And I'll just write that as R minus C. And then I will note that pi prime, remember that change in profits as we move a little bit to the right in terms of quantity, is equal to R prime minus C prime, and at the maximum it equals 0. So what that says is that at the maximum R prime equals C prime. So R prime is the change in revenue with respect to the change in quantity, delta R over delta Q. And C prime, C prime equals delta, let me go back and clarify that R, make it a nice big R, equals delta C over delta Q. And that's this delta R over delta Q, that is the change in revenue that you get when you add output, is called marginal revenue. And this change in cost is, as you add output, is called marginal cost. And so we said at the maximum that they're equal to each other, and so what that says is that the maximum marginal revenue equals marginal cost. So that's what we've shown, and now I'm going to assert that in a diagram where we put price or cost on this axis and quantity on this axis, we have a downward sloping marginal revenue curve. MR stands for marginal revenue, which remember was delta R over delta Q. And we have an upward sloping marginal cost, so that's delta C over delta Q, marginal cost. And then this is our Q star. And that's what you should take away from this perhaps peculiar sounding lecture. That is that the Q star, the quantity that a firm should choose to produce to maximize profits, is the point where marginal revenue is equal to marginal cost. And I'll stop there.